not
Clark, you
erase
want to
them.
turn
Or just a pen in general.
turn it on, then I'm going to tell you.
Yeah. Just don't use pens in general. It's not recording, is it? No, it's not. It has it. Max, it's recording.
Okay.
It's already on.
Oh,
You turned it on. I didn't turn it on.
are you sure? Recording?
Yeah, it's on.
It's counting? Okay.
You need on that? Yeah, it's definitely counting.
You will.
It's at 60.
Okay.
It's a minute.
On a graph, let's say we have 2 points. Let's say it is -3, 2, and let's say we are at, actually, let's start with the bottom. If we have +2, 3, and let's say we have +5, 3. How can we tell the distance between those 2 points? Max?
Count.
We could count.
1, 2.
Okay? If we have the lines here, there would be 2, 3, 4, and 5. Okay? So the distance between 2 and 3 would be how far?
3. 1, 2. Do you count the last line?
Well, if I'm 1, 2, I'm not at it yet.
Okay. Then 3.
Okay. What else could I do, Addie?
You could wait to get from 2/3.
How far is point 2, 3 from 5, 3?
You could subtract 5, 3. Well, 5 from 2.
If we look here, we notice that the x's are the ones that are different. And so since the x's are different, what we can do is simply subtract them. So we can subtract the 5 minus 2, giving us 3. And so the distance between those 2 points would be a total of 3 spaces. Now, let's say we have this. 2, 7, and 2, 5. Whoops, let's make it 2, 2. Now, how would we find the distance between those 2 points? Kyle?
Subtract the 7 from the 2.
Since the x's are the same, and we notice that the y's are different, we can simply subtract 7 minus 2. And 7 minus 2 would be 5. Make sense? Now, what if we have this? -4, 2, +1, 2. How can we find the distance between those 2 points? Clark?
Wouldn't it be better to count in this situation?
We could count, but we have to do something. There's going to be times that we're not going to have a graph to count on. Okay? How far is it from here to the axis? Nadia?
4.
4. From here to here is 4. From here to here is what?
5.
1, giving us a total of how far?
5.
5. So the distance between -4, 2 and +1, 2, the distance would be a total of 5. Okay? Now, let's say we have this. I'm going to write this down what we had. Let's say we had +5, 3, and we had positive 2, 3. The distance between those was a total of 3, right? That was this one here. And then we had positive 2, 7. And then we had a positive 2, 2. The distance here was 5. Now, let's say we have this. Negative 3, 5. Negative 3, negative 2. What is the distance between negative 3, 5 and negative 3, negative 2? Well, if we think about how far is it from here to the x-axis?
5.
This distance is 5. The distance from there to there is how much? 2. And so 5 plus 2 would give us 7. So the distance between 5 and 2, between these 2 points would be simply 7. Okay? Now, if you have a graph, it makes it pretty easy to recognize it. Okay? So, get out your notebooks. Yes?
I'm not trying to get ahead of things, but what if it was 3, 6, and then 3, 5?
3, positive 6.
No, like negative 3, negative 6, and then positive 3, and then a negative 7.
We're not going to worry about that yet. Okay? That'll come in about 8th grade when you start talking about Pythagorean theorem, right angles. Okay? Right triangles, where you take a squared plus b squared equals c squared. So we're not going to worry about that.
So we won't have that.
You won't have that. Okay? So, in your notebooks. Distance between 2 points. The first thing that you're going to want to do when you're trying to find the distance between 2 points is recognize if it is the x or the y that are different. Okay, so the first thing you've got to do is recognize if it is the x's or the y's that are the different or have different numbers. The next thing you're going to do is recognize are they in the same quadrant? In this situation here where we had 2, 7 and 2, 2, they were in the same quadrant. So how did we tell the distance between these 2 points? What did we do? Nadia?
We counted.
Well, let's not worry about counting. Max?
We subtracted.
We
7.
subtract. If they're in the same quadrant, we're going to subtract the absolute value of each. Now, why do you think we're going to subtract the absolute values? The reason is, let's say that we have these 2 points here. Let's say we have negative 4, 7, and we have negative 4 7 and negative 2 7. Okay, we're going to take the difference is the one that's different is the x's. So we're going to take the absolute value of negative 4 and we're going to subtract the absolute value of negative 2. It's going to get rid of the negatives basically. And so now the absolute value of negative 4 is a positive 4. The absolute value of negative 2 is a positive 2. And so now 4 minus 2 would be equal to 2. Okay? So if they're in the same quadrant, we're going to subtract the absolute value of each number. Yes?
No, I'm not going to do it like this, but if you were to subtract it, negative 4, negative 2, wouldn't it be still 2 because 2 negative?
No, it'd be a negative 2.
Oh, okay.
Okay, we're going to get into that in about a week.
Okay.
Okay? So if they're in the same quadrant, you're going to subtract the absolute value of each. If they're in different quadrants, when we had them in different quadrants, when they were in different quadrants, what we did was we found out how far it was from here to there, and then we did what? We added. So if they're in different quadrants, we're going to add the absolute value of each. Okay? Example. Let's say we have positive 3, positive 9, positive 3, positive 2. Step 1. What's the first step that we do?
Recognize if the x and y is different.
Which are different, the x's or the y's? Xander?
Y's.
The y's. So we're going to focus in on the y's. Okay? So we focus in on the y's. Now, because we know that the x's are the same, now we look at the y's. They're both positive, so are they both in the same quadrant? Yes, they are in the same quadrant. So step 2, are they in the same quadrant? Yes. So when they're in the same quadrant, now what do?
We find the
Subtract the absolute value of each one. So we're going to subtract the absolute value of positive 9 minus the absolute value of positive 2. Now, since they're both positive, would we necessarily have to do the absolute value?
No.
No, we don't necessarily, but it's just a habit. So now, the absolute value of positive 9 is?
9.
9. The absolute value of positive 2 is?
2.
2. And so now, 9 minus 2 is?
7.
7. And so the distance between the two would be 7. Let's do another example. Positive 4, negative 6, positive 4, positive 3. Step 1. We want to recognize which of the x's or y's are different. Which is different, the x's or the y's? Hayden?
The Y's.
The y's. Okay, the x's are both positive 4s, so the y's are the ones that are different. Step 2, are they in the same quadrant or different quadrant? How do you know they're indifferent? Because one's negative, one's positive. So now, when they're in different quadrants, what do? We're going to add the absolute value. So we're going to take the absolute value of negative 6, and we're going to add the absolute value of positive 3. Absolute value of negative 6 is 6. Absolute value of positive 3 is 3. 6 plus 3 is 9. And so the distance between those 2 points would be 9. Let's do another example. Which ones are different, the x's or the y's? The x's. Are they in the same or different quadrant? Nadia? How do you know they're indifferent?
One's positive,
One's positive and one's negative. So when they're in different quadrants, what do?
Add.
We add. We're going to add the absolute value of negative 5 plus the absolute value of the positive 5. The absolute value of negative 5 is 5. The absolute value of positive 5 is 5. 5 plus 5 is 10. And so the distance between those 2 points would be 10. Any questions? Does it make sense? Okay, let's get out your boards real quick.